one is then called Kest rule, and it's actually quite easy. So here what we do have is the same circle, same triangle. The only difference is we're going to actually start implementing the actual coordinates because it is the x and then y axes. So the point here is x comma y, and we're going to call this the radius. Now using the coordinate x and y, we know that the length of this one is x because we have to go x this much and then y this much to get to the point. Therefore, the length of this segment over there is just the x, and obviously the height is y. This is a right angle triangle, therefore the length of the radius is a square root of x squared plus y squared using the Pythagorean theorem. Well, it was supposed to be r squared equals x squared plus y squared, but you take the square root of the both sides so that you can isolate the r. Now, then the angle of rotation here is just the theta. Therefore, the sine theta is opposite over hypotenuse, so then it is y over r. Cosine is ka, adjacent over hypotenuse, so x over r. Tangent is opposite over adjacent, so y over x. And this actually does work all the time since it's a right angle triangle. Think of this. In the first quadrant, both x and y are positives, right? Both positives. So anything that has x and y will be positive. And not to mention, the radius is always positive. Now then the second quadrant, if you look at it, then the x value will be negative all the time, but the y value will always be positive. And your third quadrant will be pretty much the same way, except that both are negative. And then the last quadrant is then the negative of the y value and then positive of the x value. Now, using this, all of the sine, cosine, tangent will be positive. For the second quadrant, anything that has y will be positive, but anything that has x will be negative. So then the only thing that applies here is the sign being positive. For the third one, both x and y are negatives. So if they are together, it will form positive. But if they're individually there, then it's going to be negative because the r is always positive. Therefore, the tangent is going to be always positive since it has both x and y. Whereas the sine has only y, cosine has only x, so then they will become negative. Fourth quadrant, x is positive, y is negative. Therefore, anything that has only x will be positive. So then the cosine is going to be positive. So what I'm going to do is I'm going to actually put A, S, T, C. I just followed it, and hopefully you see it. It's the Kest rule in such way. So be really careful with this, okay? The C does not start from the first quadrant. People think it starts from the first quadrant. However, in this case, the Kest rule actually starts from the fourth quadrant. So the fourth quadrant is the C. Now, using this, then we can actually find the ratios or the exact values of each trigonometric ratios that is bigger than, let's say, 180 degrees or the 90 degrees even. So let's take a look at this. Find the exact value of sine 225. So let's actually draw this out. And when you draw it, it actually is very simple and easy to do. 225, hopefully you notice it, it's greater than 180. Like you know that this is 180 degrees since it's a flat rotation. And this is 270, you know that because after 180, you rotate 90 degrees more, so that's 270. And just to put, this is 90 and this is 0 or 360 degrees. So we know that 225 is somewhere over there. We know that the whole thing is 225, but we also know that this is 180, therefore the related acute angle of 225 is 45, the angle inside of the triangle. So in this case, we have 45 degrees over there. So we can say sine of 225 degrees equals sine of 45 degrees. Now, however, as we examined over here, the sign changes depending on which quadrant your angle is. So this is the third quadrant where T is dominating. That means T is the only thing that is positive. Therefore, sine then should be negative. Then we know sine 45 is a square root of 2 over 2. So sine 225 is negative square root of 2 over 2. Okay, so again, the reason why this is negative is because it's in the third quadrant. The reason why this is 45 is because the related acute angle is 45 degrees. So then let's take a look at another one. So another example over here is cosine negative 135 degrees. So same thing, sketch it very roughly. My negative degree always rotates clockwise. So I'm rotating that way, clockwise, and it says 135. So we know in this rotation, this is negative 180, this is negative 90. Therefore, my rotation is somewhere on here. And we know that this much is 135 degrees in terms of the negative y's. And I need to go slightly further to get to 180, or we can say that's this much less. Therefore, this is then 45 degrees. So again, this is in the third quadrant. Then we have to take a look at this. So the negative 135 degrees related acute angle is 45 degrees. So our cosine negative 135 degrees is equal to cosine 45 degrees. However, again, the sign changes, and this is why we have to use the Kesta system. In the third quadrant, we have t. Therefore, the cosine, which is not t, is the negative. So again, the reason why it's negative is because it's in the third quadrant, the t. The reason why the negative 135 is 45 is because the related acute angle is 45. Now the next one is MPC4. Find the sine, cosine, and tangent ratio if the terminal arm is connected to -3, -5. Leave your answer in exact value. This is a simple, okay? So it says, leave your answer in exact value, find the ratio. You're not looking for the angle. So what is sine theta equal to? Not what the angle theta is equal to. So let's plot -3, -5 first. So somewhere, I'll say here, right? -3, -5 is somewhere here, and draw the triangle. Remember, the triangle is always with the x-axis, not the y-axis. So this is -3, -5. Well, we know this is x value, this is y value. Remember, the radius was square root of x squared plus y squared. And we know that this is going to be the theta, the rotational angle. So then we can say the radius is -3 squared plus -5 squared, which gives me then square root of 34. Then for the sine theta, we just follow. Remember, the sine theta was y over r from above. So the y is -5, so -5 over square root of 34. Cosine theta is then x over r, so then it is -3 over square root of 34. Tangent theta is y over x, therefore it is -5 over -3. Negative divided by negative is positive, so it will be 5 over 3. Now, some teachers do care about rationalization right there, so make sure you do if you need to. If you do rationalize it, then this actually becomes -5 square root of 34 over 34, and this is -3 square root of 34 over 34 in case that you actually did it. So hopefully this was okay. The skill 3 is not easy, so make sure you do review. Make sure you do leave a comment if you need extra explanation. Otherwise, it's going to be very confusing later on. Thank you so much for watching YOLO channel. I'll see you guys later. Bye bye.